It's my pleasure now to introduce Doug Tallamy, our first speaker. Doug is a professor in the Department of Entomology and Wildlife Ecology at the University of Delaware. And I'd like to start by telling two short stories about the impact that Doug has had on me and people I know. In 2019, I was thinking about retiring. It takes a lot of time to put this tour on, and there were many things that I wanted to do in life that I wasn't getting to. But then I heard Doug speak, and I realized that encouraging people to garden with native plants wasn't just a good thing to do. It was really a necessity, as he puts it, quote, if we are to continue living happily on this planet, end quote. So I set aside my dreams of reading more books and exercising and spending time with my family, and I redoubled my efforts with the tour. Doug's talk has changed not only my life, but those of many other people who've heard him speak or read his books. So I'd like to tell you about my friend Ruth, who I have known for decades, and my friend Shannon, who I've known for 6 years. And I know that both of them love me and would do anything for me, but they had both heard me talking about native plants for years, and they just shrugged it off. I think that they thought it was like I was a Hare Krishna or something, and that it was fine for me, but they were not going there. And then they heard Doug speak during the first online Bringing Back the Natives garden tour that we put on in 2020 when the pandemic came, and they were both suddenly and unexpectedly and completely convinced. And they both told me separately, immediately after hearing him, that they were putting in native plant gardens, and they both did. And you can see Ruth's beautiful Berkeley garden on the Bringing Back the Natives garden tour this year on Saturday, May 6th. She had her garden on the tour last year also. And we would have had Shannon's Richmond garden on the tour, but sadly she has moved. So I hope that this talk has the same effect on you that it had on me and my friends, and that I have all of your gardens on the tour one day. With that, let me introduce Doug Tallamy, who'll be giving the talk, Restoring the Little Things That Run the World, Why It Matters, and What We Can Do.
We do want to talk about restoring the little things that run the world because they are declining. But before we do that, I want to mention that Kathy asked me to make an attempt to westernize my talk. Of course, we do our research in the East. All of my slides are from the East. And just to make it a little bit more relevant to folks in California, she sought a number of photographers and sent me a whole bunch of slides, including her own, which I've incorporated in here. So hopefully you'll be seeing some things that you recognize on a day-to-day basis. So thank you to Barry and Kitty and Amy and Sally and Pam and David and Alan and Mark, and then Kathy herself. Okay, we have two choices. We can create landscapes in which nature thrives, such as this, or we can create landscapes that are ecologically dead. The first option is going to sustain us as humans. The second will not. So to restore nature, to create these functional landscapes, we've got to restore the specialized relationships that are nature. And likewise, if we're going to restore insect populations, we have to restore the specialized relationships that sustain them, such as this one. This is the Doll Sphinx caterpillar. It's a specialist on Western species of juniper. Not only does it have the physiological ability to eat juniper, which is a pretty toxic plant, it also looks exactly like them, so it can do that without being eaten by birds. Acorn weevils, of course, depend entirely on acorns, and you don't have acorns unless you have your wonderful species of California oaks. And if you have your California oaks, you often have mistletoe. And if you have mistletoe, you may have this beautiful moth, the beloved Emarginia, which is a specialist on mistletoe. You're not going to have the beautiful Pacific green sphinx moth unless you have evening primrose. You're not going to have 13 species of native bees that specialize on sunflowers. They can only reproduce on the pollen of sunflowers unless you have those sunflowers. You're not going to have pileated woodpeckers unless you have lots of carpenter ants, because that's what they rear their young on. And you won't have carpenter ants unless you have the big trees to produce them. So specialization of these types is in the natural world is, it's the rule, particularly specialization focused on food webs. It's the rule, not the exception, and it always starts with plants. There are lots of animals that depend on the specialized relationships that insects have with plants. So let's point out a few of those. This is the chestnut-backed chickadee. Most people think of chickadees as being seed eaters because they're one of the most common birds that are feeders all winter long. And of course, they are eating seeds. But when it comes time to make more chickadees, when it comes time to reproduce, they can't feed their baby seeds. Their babies cannot eat seeds, so they switch to insects, and most of those insects are caterpillars. We have Carolina chickadee here in home. I'm in Southwest Pennsylvania, and we have the Carolina chickadee. It also is a seed eater during the winter, but during reproduction, it switches to caterpillars. And if it's in a healthy environment, it will feed its young exclusively on caterpillars. And in fact, most birds in the lower 48 states are rearing their young on insects, and most of those insects are caterpillars. We actually have data to support this. You're looking at 20 families of birds. The green bars are the percentage of the nestling diet that are caterpillars. And in 16 of the 20 families, caterpillars dominate the nestling diet. So imagine what would happen to bird reproduction in those 16 families if caterpillars were to disappear. Caterpillars turn out to be essential to most terrestrial food webs. It turns out that they are transferring more energy from plants to other animals than any other type of plant eater. So they're critical insects in our terrestrial ecosystems, and we might want to ask why. What is special about caterpillars? Why do so many things want to eat them? Well, there are a number of reasons. One is that they are, most of are relatively soft. So if you think of this caterpillar as a little sausage with a thin wrapper, the thin wrapper is its exoskeleton, which is not digestible, so birds don't want a lot of exoskeleton. And then it's packed with lots of good things to eat. And because it's soft, you can stuff it down the throat of your offspring without fear of injuring them. And if you've ever watched a parent bird feed their young, that's what they do. They're pretty rough. It's like a plunger. They just stuff it down there. So they're soft, but they're also relatively large. One medium-sized caterpillar is equal to the biomass of 200 aphids. Some of our smaller birds do chase aphids around, but you want to chase 200 aphids or get one caterpillar. They're nutritious. They're very high in protein, very high in fat. They have a very low percentage of chitin, of exoskeleton, compared to things like beetles, which are not like sausages. They're like little tanks. Lots of exoskeleton that's not digestible. And they have a lot of pointy edges too. And it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. Now, I mentioned carotenoids not because I love organic chemistry, but because I am a vertebrate. You are vertebrates, I presume. And vertebrates don't make carotenoids. Only plants make carotenoids, yet they are an essential component of vertebrate diets. So we need carotenoids, the birds need carotenoids, and we have to get them from plants. And that's why my wife Cindy says I should eat my carrots to get my beta carotene, and my tomatoes to get my lycopene, my whatever that is to get my lutein. She makes sure I get all of those things because they stimulate my immune system. I am generally healthier when I have access to lots of carotenoids. They're antioxidants. They run around our body and protect our DNA from oxidative damage. They improve color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but it turns out she was right. They improve sperm vitality, improve sexual attractiveness. We're talking about birds here now. This is a prothonotary warbler, male, and he is bright yellow because he's taken carotenoids and made pigments out of them. He's had access to lots of luteins, and he puts those pigments in his feathers, and the brighter yellow he is, the more ladies he attracts. Well, chickadees are birds. They're not making their own carotenoids, so they have to get them from plants. But again, they're not eating plants during reproduction, so they have to get them indirectly from plants by eating something that did eat plants. And if we look at the carotenoid content of typical bird prey items, we see that they're not equal. The first two bars here are caterpillars, and they have the most carotenoids by far, followed by orthopterans, things like crickets and grasshoppers. The adult caterpillars, the butterflies and moths, are way down here because the adults are not eating green leaves. That's where the carotenoids come from. Then way over here, we've got earthworms. So the early bird gets the worm, but he does not get any carotenoids when he gets the worm. Does this matter? Well, it does, according to work done by my PhD student, Ashley Kennedy, who put GoPro cameras on the tops of bluebird boxes. She had a lot of bluebird boxes and a lot of GoPro cameras, and they took a picture once every second. So she actually had to go through more than 1 million pictures to get the data here. But there's a direct correlation between the frequency with which a prey item is brought back to the nest and the amount of carotenoids that that prey item has. So caterpillars are brought back more often than anything else, followed by those orthopteroids, and then everybody else is nestled down here. So what this is saying is that caterpillars may not be optional parts of bird diets. It's starting to look like they are essential components of bird diets. And that means you're not going to have chickadees if you don't have enough caterpillars. And that's true for so many other types of birds. And that means we need to know how much is enough. How many caterpillars does it take to make a clutch of birds? Well, again, let's look at chickadees. We've got data for chickadees. I wanted to know what chickadees were feeding their young several years ago. So I put a box up in my backyard. I set my camera up so I could take pictures of what those chickadees were feeding their young. And I found out that it takes a lot of caterpillars to rear chickadees. A pair of chickadees can deliver a caterpillar to the nest once every 3 minutes. I watched them for 27 minutes at one point, and they brought in 30 caterpillars. How did they do that? By bringing in more than one caterpillar at a time. And sometimes they brought in a whole bunch. And they're working very hard. They're doing this from 6 a.m. to 8 p.m. at night. Well, the next question is, how many species of caterpillars do chickadees bring back to the nest? And it turns out this is a very important question. I watched them for 3 hours, and during that 3 hours, they brought back 17 species of caterpillars. Now remember, this is in my yard, and chickadees only forage about 50 meters from the nest. So they got 17 species of caterpillars in my yard within 3 hours, within 50 meters of the nest. Why is that important? It's important because if I had 1 or 2 species of caterpillars in my yard, and it happened to be a bad year for those species, like this year, I'm predicting this is going to be a tough year for caterpillars because it's been so cold and so rainy here. There wouldn't be nearly enough caterpillars for the chickadees to be able to successfully reproduce. But if I have 17 species of caterpillars, or 34, or 134, and this got me curious to ask how many species of caterpillars are there in my yard. So I started counting them. I am up to 938 species, and I'm still going. Get new ones all the time. That means that some combination of all these species, no matter what the weather is, will create enough food so that chickadees get to reproduce any year, again, regardless of the weather. So this type of diversity, I've got that many caterpillars in my yard because I've got the plants that make those caterpillars. This is stability in the food web, creating stability. This is diversity in the food web, creating stability in that food web. You've heard that diversity is a good thing, and this is one of the main reasons it is. It means that you can have creatures reproducing every year, regardless of the variability around them. It stabilizes ecosystems. There was a guy by the name of Brewer way back in 1961, Richard Brewer, who was working on chickadees. And one of the things he needed to know was how many caterpillars they brought back to the nest every day. So he watched a whole bunch of nests, and it turned out to be between 390 and 570 caterpillars per day, depending on the number of chicks in the nest. And they're in the nest for 16 days. So that is 6,000 to 9,000 caterpillars just to get them to the point where they leave the nest. Now, at that point, he couldn't count them anymore. They're flying all around, but the parents continue to feed the babies for another 24 days after they leave the nest. So who knows how many thousands of caterpillars are required to make one clutch of chickadees. Is this true for other birds? Absolutely. There's data from a number of birds now. You have Wilson's warblers breeding there in California. A guy by the name of Stewart watched Wilson's warblers for 5 days. Pair brought in 4,060 caterpillars just in 5 days to the nest. And these are tiny birds, around 1/3 of an ounce. What if I wanted to have a Lewis's woodpecker in my yard? It's 9 times heavier than a chickadee. How many caterpillars does that take? And I don't want just chickadees and Wilson's warblers and Lewis's woodpeckers. I want a whole community of birds. And if I lived in California, I would want Steller's jay. I would want spotted towhees, white-breasted and red-breasted nuthatches. I would want fox sparrows, black-headed grosbeaks, downy woodpeckers, hairy woodpeckers. I'd want both ruby crown and golden crown kinglets, western bluebirds, the varied thrush, western tanagers, brown creepers. I'm very selfish. I want all of these birds in my yard. I want evening grosbeaks and black phoebes and bush tits and Buick's friends and Oregon juncos, tree swallows, western wood peewees, oak titmice, blue-gray gnatcatchers. And then I want all the warblers too. I want black-throated gray warblers, orange crown warblers, Townsend's warblers, common yellowthroat, yellow warblers, and of course, I want Anna's hummingbird and the other hummingbirds. And you might say, wait a minute, hummingbirds don't eat insects, they eat sugar water. And of course they do. But first part is wrong. They do eat insects. 80 to 90% of a hummingbird's diet is insects and spiders. And then they go get the sugar water. We only see them getting the sugar water, but you don't make a bird out of sugar water. And that is true for 96% of the terrestrial birds in North America. They are rearing their young on insects, not seeds and berries. And this is news to a lot of people. Most people think that birds do eat seeds and berries. That's why we see them in our feeders. And many do after they have reproduced. But when they're reproducing, when they're making more birds, which happens to be a really important time in their life history, they need the protein from insects and other arthropods. So no insects, no baby birds. A bit of a generalization, but not much. That means we need to design landscapes that are capable of producing a lot of insects. How do we do that? How do we get the diversity and numbers of insects that we're talking about here? Well, to answer this question, we have to return to specialized relationships. We have to consider the most common type of specialized relationship that happens all over the planet, and that is the one between the insects that eat plants and the plants themselves. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their tissues with nasty tasting chemicals, secondary metabolic compounds that make those tissues either bitter or downright toxic. And it's an extremely effective defense that keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there. It's not because there are no insects that want to eat those plants. It's because most of the insects that are out there cannot eat those plants. And if you don't believe me, when you go outside, first leaf you see, eat it. See if you like it. You're not gonna like it. You're not gonna like it. But we do know that insects eat plants. So how do they do that? How do they eat all those toxic plants? Well, this is where the specialization comes in. 90% of the insects that eat plants are what we call host plant specialists, which means over evolutionary time, they develop a very tight relationship with a particular lineage of plants. They get good at circumventing that lineage of plants' defenses. They build the enzymes that detoxify and store and excrete the nasty compounds, the behavioral adaptations and the life history adaptations that allow them to reduce their exposure to all the plant defenses. But again, it takes a long period of evolutionary exposure before all of those adaptations fall into place. It does not happen overnight. Let's use the monarch butterfly as an example, because many of you know at least part of the story of specialization in the monarch. You probably know that monarchs are specialists on milkweeds, and you may know that milkweeds are toxic plants. So when you're outside eating plants, don't eat a milkweed. They're filled with cardiac glycosides, and if you eat enough of it, it will stop your heart. That's what cardiac glycosides do. Well, it doesn't stop the monarch's heart, and they do have a heart, by the way, because they've got the enzymes that detoxify those cardiac glycosides. But what about the sticky latex sap that gives milkweeds its common name? When you break open a milkweed leaf, all this white goo comes out. If you get it on your finger, you typically wipe it off right away. But if you don't wipe it off, if you let it sit there for a few minutes, it starts to gel. When it's exposed to oxygen, it turns into a chewing gum-like substance. And if that gets on the mandibles of a caterpillar, it will glue its mouth shut. And then the caterpillar starves to death. So it's an effective defense. Well, this, of course, is a caterpillar that eats milkweeds. That's the monarch caterpillar. How does it eat milkweeds without gluing its mouth part shut? This is something you can watch in your yard if you have milkweeds. The caterpillar will walk onto a new leaf, typically goes to the end of the leaf, and it starts to eat. And if it encounters any latex sap at all, it'll stop eating immediately, turn around, crawl back up that leaf, maybe 2/3 of the way, and it starts to chew through the midrib. And it chews till it has completely severed the midrib. And what it's done is block the flow of latex sap from this end of the leaf to this end of the leaf. So now all of this part of the leaf, the distal part of the leaf, is latex free. Now the caterpillar can turn around, go back down to the end of the leaf, and it can eat without any latex sap coming out at all. It's a very simple behavioral adaptation that it diffuses that effective defense of milkweeds. It also flags milkweed leaves. So if you're a monarch hunter, you can drive down the road, look at a milkweed patch. If you see flagged leaves like this, you know that monarchs have been around. Well, those are the upsides of specialization for the monarch. It gets to eat a plant that is unavailable to most other insects because they don't have the specialized adaptations to get around milkweed defenses. There is a downside to specialization, though, and it is that now anything it specializes on a particular plant ends up only being able to eat that particular plant. Now, monarchs can only eat milkweeds. And that is fine as long as there are a lot of milkweeds around. But if we take them away, it doesn't work for the monarch. We have 2,137 plant genera in North America, and monarchs can only eat one, the genus Asclepius. And because we have lost so many of our milkweeds, on both sides of the Rocky Mountains, in California, your monarchs are in deep trouble. They've declined 99% since 1976 because of development, agriculture, drought, and fire. You've lost a lot of your milkweeds. So if you want to keep the monarchs around, we've got to plant milkweeds. Okay, we can use this knowledge of specialization, host plant specialization, to consciously rebuild food webs wherever we want. If we're talking about doing it at home, let's rebuild them in our yards. If we understand what the components of those food webs are. And I'm going to use the white-eyed vireo as an example. That's a bird from my yard. I'm going to use it as an example because this is the nest that my wife Cindy found a few years ago. Now, in order to reconstruct the food web of the white-eyed vireo, I have to take pictures of the caterpillars that they're bringing back to the babies. If I can identify the caterpillar, we know a lot about what caterpillars eat. Then I will know what plant was necessary to make the food that feeds these babies. Apparently they knew all that, so they built their nest really low, and I could set my camera up again and take pictures of what was happening. And this is what was happening. They were bringing back caterpillars like the blinded sphinx moth. It's a specialist on black cherry in my yard. We have a lot of black cherries making blinded sphinx moths, so the babies get to eat. This little guy is the chestnut schizura. It's a specialist, despite its common name, a specialist on native viburnums. At our house, that's viburnum dentatum, arrowwood viburnum. I know we have arrowwood viburnum because we planted it. Our yard was mowed for hay before we moved in, and there weren't many plants here. So we put in the viburnums. Chestnut schizuras are here, and the babies get to eat. This guy with the white stripe is the drab prominent, a specialist on sycamore. Now, we did not plant sycamore, but there was a big wind maybe 2 years after we moved in and blew in some sycamore seeds. So it's been 18 years since then. One landed in my cold frame and germinated. I'm not very good at weeding things out. It's got to be 80 feet tall at this point. So I don't have a cold frame anymore, but I do have lots of drab prominence, and the babies get to eat. So on and on we go. This is the 8-spotted forester moth, a specialist on native grapes. We have lots of those. The lunate zale, another specialist on black cherry. This is the spicebush swallowtail. It's a specialist on spicebush and a close relative sassafras. This is one of the caterpillars that when it's attacked, it blows up its prothorax and exposes eyes on its back that make it look like a tree snake. It's supposed to scare the bird. It didn't work this time. This is the tufted bird dropping moth, another specialist on black cherries. So black cherry is emerging as a really important component of this bird's food web. But these guys are hungry. They need a lot more than that. So let's put some black walnut into the landscape. If we do that, we get the walnut sphinx, the gray-edged bomoloka, the black blotch caesura, the bride. These are all specialists on black walnut in my yard. Native maples that give us Plagodes inchworms, the green striped maple worm, the maple bantam dagger moth, and of course, many other species. Native elms give us the four-horned sphinx, the double-toothed prominent, the interrupted dagger moth, and again, many others. Remember, 90% of the insects that are required to keep these birds alive will not be in our yards unless we have the plants on which they specialize with, which they have co-evolved. So if I want the mustard sallow, I need witch hazel. If I want the hackberry emperor, I need hackberry. If I want Coculio asteroides, I need native asters. The Arcidra flower moth and the brown hooded owlet need goldenrod. The hog sphinx, Pandora sphinx, abbot sphinx all need Virginia creeper. Redbud leaf roller needs redbud. The gray furcula needs native willows. The turbulent phosphophila needs greenbrier. And the orange tufted oneida, the yellow vested moth, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red humped oakworm, the orange humped oakworm, the pink striped oakworm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the white blotch heterocampa, the oblique heterocampa, the red line panapoda, the laugher, and literally hundreds more will not be in our yards if we don't have oaks. Because it turns out oaks are the most powerful plant we can put in our yards to maintain food webs, not just in my yard, not just in your yards, but in 84% of the counties of North America. Why do we want all these insects? Well, we talked about birds. They want them, but it turns out insects are critical components of most of the terrestrial food webs that are out there. All spiders need insects, or they eat other spiders that ate insects. And I know a lot of people don't like spiders, but look who does. It is the second most important component of bird food webs. And of course, they're valuable predators. If we lost our spiders, we'd have a lot more mosquitoes that we don't need. We have a lot of insect predators that are eating those insect herbivores. So again, if we lose the herbivores, we'd lose the predators, and they themselves are valuable components of food webs. If we lost our insects, we'd lose our frogs, we'd lose our toads, we would lose all of the amphibians because they all eat insects. So do our lizards, so do our bats, so do our rodents. Excuse me. Why do these creatures all want insects? Because they're really good food. Pound for pound, there's twice as much protein in insect meat as there is in beef. And insects have organs in their abdomen called fat bodies that are loaded with fats and lipids that are high energy compounds that allows these little guys to grow quickly, reproduce quickly. And if you're a rodent, that's what you want to do because you're an important component of food webs too. But it's the same reason that larger organisms are eating insects. They're just really good food. This is a skunk. They eat insects. They're digging up your yard to get the grubs that are in your yard. Possums eat a lot of insects. Raccoons eat a lot of insects. And even things we don't think of as insectivores eat a lot of insects. Like our friend the red fox here. 25% of its diet is insects. A full quarter of its diet is insects. 23% of a black bear's diet is insects. So even the big guys need insects. And even if you don't eat insects, you need insects. This is a sharp-shinned hawk. It's a bird predator. You might think, well, I can get rid of all the insects in my neighborhood and still have sharp-shinned hawks. But think about it. If you got rid of the insects in your neighborhood, you would get rid of the birds that this guy's eating. So he needs them indirectly. Same with the garter snakes, not eating insects directly, but it's eating the frogs and the toads that ate insects. Point is that a world without insects is a world without biological diversity. And Edward O. Wilson, E.O. Wilson, told us decades ago that a world without insects is a world without humans. And that makes it something that's pretty important here. He wrote this paper, The Little Things that Run the World, back in 1987, where he predicted if insects were to disappear, lots of nasty things would happen. First of all, most of the flowering plants would go extinct, and that would end energy flow through our terrestrial food webs, which would cause the collapse of the food webs that support the animals that we know and love. So we would lose our amphibians and reptiles and birds and mammals. The biosphere, the living portion of the earth, would rot instead of having the rapid turnover of nutrients because of the insect decomposers. We would lose those decomposers and be nothing left. And of course, humans would not survive any of those drastic changes. Well, we ignored Wilson's warnings, and that's why we now have headlines like this. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, they have to go back and read E.O.'s paper because he outlined it very clearly. It's not good news. Insect declines are being reported at least all over the temperate zone. Not much work in the tropics, but again, not good news. And these headlines are coming one after another. This one, the UN is now predicting we're going to lose 1 million species, possibly in the next 20 years. And humans will suffer. You bet. You bet we'll suffer. We can't afford to lose these species. And most of the species, again, are insects. So we have serious insect declines. A lot of people want to study it more. That's great, but we also have to stop them. We've got to reverse it. We don't need any more research to convince us that it's real. And these are some of the causes: misuse and overuse of pesticides, the omnipresent habitat loss. Every time you build a house, you don't have the insects that used to be on that property anymore. The profligate use of non-native ornamental plants from someplace else that don't allow those specialized relationships to develop. They often escape into our natural areas and become invasive species. We've got problems with security lights at night. We've got roadside mortality. And of course, we have climate change. There's good news here, and that is the first, what are there, 6 causes here? The first 6 causes are easily addressed. Each one of us can address each one of these causes, and I'll tell you how. Climate change is a little bit tougher. If I asked you to solve climate change yourself, you wouldn't be able to do it. You could stop driving your SUV, and yes, it would help, but you'd see no measurable difference. You can address the problem up here and see measurable differences, and we'll talk about how to do that. What's happening to insectivores, the things that eat those insects? Well, let's again look at the birds. Birds are now our charismatic megafauna. A lot of people like birds. And of course, the news is not good. Another headline we just had a few months ago: we've lost 3 billion birds in the last 45 years. Let me remind you what a billion is. A million seconds is 12 days. A billion seconds is 31.7 years. So a billion's a big figure. We now have 3 billion fewer breeding birds in North America. 432 species of North American birds now considered at risk of extinction. Not because there's only 5 left of each one. Many of these are common birds, but because their population trajectories are heading down so rapidly. That's the signal for impending extinction at this point. So again, not good news. I think that our only viable option is to learn how to live in ecological harmony with the natural world that sustains us, to learn how to live sustainably with a natural world that sustains us. So let's look at some of the problems we have. One is, we have parks and we have preserves. You certainly have some wonderful ones in California. Why can't they preserve the biodiversity that we need? It's a good question. And the answer is, they're too small and they're too isolated from each other. When you take a large area like this and you shrink it down to a little habitat fragment, and through most of the country, this is what we have. It doesn't have to be this small, but you're taking large populations and shrinking them down to small or tiny populations. And that's the big problem. Small populations are highly vulnerable to local extinction. Why? Well, when you have a large population, the top line here, all populations fluctuate. In good times, they go up. Bad times, they go down. But if you're a large population, even in your down cycle, there's enough individuals that you can increase quickly when times get better. But small populations in their normal fluctuations often hit 0. They blink out of their little habitat patch. And then they're gone. Unless they recolonize, that becomes local extinction. And picture a box turtle, for example, crossing a major highway. It doesn't happen anymore. So local extinction is what we need to worry about. A lot of people only worry about global extinction. I don't care if box turtles are doing fine in the Great Smoky Mountains at this point. We need species to run the ecosystems where we are everywhere, because the number of species in an ecosystem determines how well it functions. And we need highly functioning ecosystems everywhere because we need to produce ecosystem services everywhere because we have so many humans everywhere, not just in our parks and our preserves. David Quammen has an excellent analogy between a Persian rug and ecosystems. This is a Persian rug, a functional Persian rug. This is not 71 Persian rugs. It's 71 fragments that are not functioning as a Persian rug. And this is pretty much what we've done to our ecosystems. So there's data from all over the world, and some of the studies are quite long, over 100 years in length at this point, but they're all telling us the same thing. We have not left enough nature out there to sustain the species that run our ecosystems. Not only that, so we're just doing a little bit of bad news here. The viable habitats we have left are fragmented, but they are also invaded with what we call invasive species. Let's just talk about invasive plants. Now, you people in California know about invasive plants. People everywhere know about invasive plants. They are every place. This is one of those little habitat fragments near where I live called White Clay Creek State Park. And every bit of green you're seeing there is a plant from Asia. I took this picture in March before our deciduous plants leaf out. The plants from Asia leaf out first. So it's a very good time to see what your alien plant load is. And it's about a third of the vegetation in parks most places are unable to support the insects that run our ecosystems because they are plants from someplace else and our insects have not adapted to them. How do we know this? Well, that's what we've been studying in my lab at the University of Delaware for, I don't know, 13, 14 years now. We can measure it. We can measure what happens to local food webs when we take away the native plant communities that used to support them and replace them with plants from outside of those communities. Here's one simple study that was recently published. We simply went into hedgerows in Maryland, Pennsylvania, and Delaware that were invaded by non-native plants. So here you see a lot of autumn olive and a lot of porcelain berry and multiflora rose and the other things we have here, and compared the caterpillar communities in those hedgerows with caterpillar communities in hedgerows that were not invaded, that were mostly native plants. We found a 68% reduction in the number of species in those invaded hedgerows, a 91% reduction in the abundance of the caterpillars in those hedgerows, and a 96% reduction in the biomass, the amount of energy flowing through that food web in the invaded habitats. So if you think of caterpillars as bird food, you got a 96% reduction in the amount of bird food in areas where these non-native plants have invaded. Does this matter? Well, it matters if you're this common yellow throat trying to feed your young. Some people have said, well, you know, he can just forage 96% harder to get the same amount of food, but he can't. He's already foraging all day long, 156 trips a day. He can't do that 96% harder. So the prediction is you'll have 96% less bird biomass in a habitat that's been invaded by these plants. And that's reflecting very much those terrible figures we just talked about. Trying to personalize this a little bit. What if I said, introduced plants have reduced your bank account by 96%? I think you would get it right away that this is not good. This is not good. Well, insects are the currency in our ecological bank account, and we have to start thinking seriously about getting those populations back up. I want you to think about it from the perspective of the birds that require these insects. So think of yourself as this magnolia warbler. You're now this magnolia warbler. You have just finished overwintering in the Talamanca Mountains of Costa Rica. It is time for you to fly north to reproduce, and you're about to undergo the most dangerous thing you're ever going to do: migration. Predation risks are high. The energy expenditure is fantastic. Migrants lose 35% of their body weight on long flights like crossing the Gulf of Mexico, but any long flight they do. And when they stop, they have to put that weight back up. People are looking at the stomach contents of tiger sharks in the Gulf of Mexico. And during migration, they're filled with migrating birds that just don't make it. They come down right in the middle of the ocean. So migration is hard. And you might ask the question, the legitimate question, if it's so hard, why did it evolve in birds? Why would they bother to do it? Why don't they stay where they are? Well, migration evolved for the same reasons that anything evolves. The benefits of migration outweighed the costs. The costs are high, but the benefits are even higher. What are those benefits? Well, in the temperate zone in North America, in the spring, we have this giant flush of new leaves. And following that giant flush of new leaves is a giant flush of the insects that eat those leaves. So you have this big flush of food that enables birds that come up and take advantage of that to actually make more babies. That does not happen in the tropics. The tropics are much more steady. There's a lot of competition for food in the tropics. So if you take advantage of this spring bonanza of food in the temperate zone, instead of rearing 2 to 4 offspring per year, you can rear 3 to 6 offspring per year. Doesn't seem like a big difference, but it's enough to balance the costs of migration. So let me emphasize this. Bird migration was only adaptive because there were so many insects that were seasonally available in the temperate zone. This study came out 2018, talking about, I don't know how they measured it, but they claimed that birds eat 500 million tons of insects each year. And they presented it as if, well, this is great because birds are eating 500 million tons of pests each year. Believe me, insects are not all pests. Let's rewrite it and just say birds require 500 million tons of insects each year. And if you take away that tonnage of insects, you're going to take away the birds. So these types of insect declines are not just affecting a few obscure migrating birds. It's most of the birds that we know and love. There are 386 species of neotropical migrants that may no longer have enough insects to justify that migration. It's our swallows and our swifts, our orioles, our hummingbirds, our vireos and tanagers, our buntings, our flycatchers and thrushes, our warblers, and we have a lot of species of warblers, our bobolinks, our nightjars. All of these birds are at risk because the reason they're coming north is to get all the insects, and we don't have those insects there anymore. So which plants should we be sure to have in our landscapes? The plants that are going to make the most insects, and there's two ways of finding out what those plants are. We helped create a tool that is now launched on the National Wildlife Federation website called Native Plant Finder. You go to this tool, put in your zip code, and the ranked list of woody and herbaceous plants for your county will pop up. So the excuse, I don't know what to plant to help wildlife in my yard, is no longer a good excuse. You can find out what it is. And this works really well in most parts of the country, except in California, for two reasons. You've got a number of biomes in California. You've got these mountains right in the middle that depends on which side of the mountain you're on. And your counties are huge. So there's no one plant that's going to work in all places in a county. So luckily the California Native Plant Society created Calscape, and you're going to get a little workshop on how to do Calscape at the end here, it's an excellent tool. I wish every state had a Calscape. They've got GPS coordinates for where every single native plant in the state is located. So you can look at those maps and very quickly identify the plants that are appropriate for exactly where you live. Very powerful tool. But when we made these tools, a very striking pattern jumped out at us. And that was that it's actually a very few species of native plants are making most of the food. About 5% of our native plants are making about 75% of the food that drives these food webs. So I started calling those keystone plants. And what it means is that all natives are not created equal. Some are really good, some are okay, and some aren't making a whole lot of food at all. So the question is no longer, are natives better than non-natives? On average, they certainly are. But the question really should be, do I want an ecologically powerful plant in my yard? Or do I want a benign one that's not going to contribute anything, or even worse, an unproductive plant that's going to escape and invade local habitats? I get emails a couple times a year from people saying, don't I know that ginkgos, ginkgo biloba from Asia, actually grew in North America 7 million years ago? So that makes them native, and that's why we can plant them. Well, if being native was our only criterion, well, I'd still argue with that, but that's not our metric anymore. Our metric is, how many caterpillars is it making? Ginkgos make 0. So I don't care if it grew on the moon 7 million years ago, it is not a productive plant in North American landscapes now. It's good for other reasons, but if you want to help wildlife, ginkgo is not going to do it. Compared to your oaks, 270 species of caterpillars produced by California oaks. Which are you going to plant if you want to help your local birds? Eucalyptus. Californians love your eucalyptus. Only support 5 species of native caterpillars. Compared to your local prunus, 246 species of caterpillars. These are your cherries, like holly leaf cherry. Your zelkova, no caterpillars. Compared to ceanothus, like California lilac, 93 species of caterpillars supported by that. Mike, Kathy's husband, made this very handy graph, which might be a little hard for you to read. So we're gonna dwell on this a bit at the end of the talk. But the green bars are some of the native ornamentals that can be used in California landscapes. And the red ones are typical ornamentals that are non-native. And this is the number of caterpillar species that they support. So look, here's the difference between regular species and those keystone species. Look at how big the oaks and the cherries are compared to everything else. But look how big all the green bars are compared to the red bars. These guys are not going to support life in our ecosystems. So think of your yard, your plants in your yard, as if they were bird feeders, because they can be if you pick the right plants. So there you go, they're bird feeders. Now you get to decide how well you're going to feed the birds. You can feed them a lot, or you can feed them just a little bit. This is what the landscapes around me look like, giant lawns with very few plants in them. You can choose the plants that actually make the caterpillars. You can have food in your bird feeders, in other words, or you can have plants where the bird feeders are empty. There's the ginkgo back there. No caterpillars. It's a big tree, but it's just not contributing. And when we don't think about the role of these keystone species or genera in our landscapes, we're not fooling the birds. I'm going to share a little bit of data from my PhD student, Desiree Narango. She's not my student anymore, she's graduated, but she looked at Carolina chickadee reproduction in the suburbs of Washington, D.C. As a function of the landscape plants around where the nest box was. She got to compare when most of the landscape plants were native and most of the landscape plants were non-native, and compared chickadee breeding success. So this is a typical breeding territory of a pair of chickadees. The star is where the nest is. Again, it's about 50 meters from the nest is where they're foraging. The blue areas are the trees on which they did 95% of their foraging. So let's look at what those species are. You may not recognize them, but these are all native species in the DC area. Basswood and sweet gum and American elm, black cherry, 2 species of oaks. Let's also look at the plants that the birds did not forage on. And they're all the plants from Asia. We got Japanese maples and silk tree. Here's our friend the ginkgo, black poplar, crepe myrtles, saucer magnolia. And it's very easy to picture a landscape where these are the dominant plants. So that allowed Desiree to compare chickadee reproductive success in those 2 types of landscapes. And when they were dominated by non-native plants, they produced 75% fewer caterpillars. So right away, you've reduced the amount of food for the chickadees by 75%. Those landscapes were 60% less likely to have breeding chickadees at all. So even though there's a nest box up, and nest box, chickadees are tree hole breeders that's always in short supply, the birds would come, they'd look at the landscape and say, there's simply not enough food here. We're not even going to bother. If they did bother, they laid 1.5 fewer eggs. Those nests were 29% less likely to survive at all. They produced 1.2 fewer fledglings. It took them 1.5 days longer to do it. And the chicks that left the nest were lighter than the ones that were in more native habitats. And you might say, well, these aren't huge differences. But when you put all that together in a population growth model, this is what you get. As a percentage of the non-native plants in the landscape, from 0% to 100%. This dotted line represent replacement rate. The population at this dotted line is reproducing as many chicks, as many offspring as adults that are dying. So it's a sustainable population that's not growing, but it's not shrinking. Anything above that dotted line is a growing population, but anything below it is a shrinking population. And right here is where they overlap, around 30% non-native plants. So if you have a landscape where 70% of the plant biomass are productive native plants, you can have a sustainable breeding bird population. So that's good. This is the first time this has been measured for any bird anywhere, but it also suggests that there's room for compromise. 30% of your landscape can be non-native plants that aren't contributing much. As long as they're not invasive, they're not going to destroy your ecosystem. And this is good news. If I told people that you weren't allowed to have any non-native ornamental plants, I'd have very few people listening to me. But you can, as long as you get those big dominant productive keystone plants in your landscape. Desiree also looked at the number of migrating birds that passed through her study sites in Washington, D.C. It was 51 species. Now remember, migrants fly all night long. They do not fly around our cities. They fly right through them. And when it comes dawn, around 4 in the morning, they come down, and what they have to do, everybody says they've got to rest, but what they really have to do is gas up. They've got to refuel by eating the insects that are going to put that body weight back on. And if they come down in the land of ginkgo, there's nothing to eat, and that's the end of the migration. That's the end of the bird. So a lot of people say, well, I don't own a property that's big enough to support a breeding bird. And that may be true. But if you own a property big enough to support a single plant that makes caterpillars, you can support migrating birds. And believe me, they will appreciate it if you do that. They will stop. They will eat those caterpillars. So what we're talking about here really is nothing less than rebuilding the Earth's carrying capacity, its ability to support life. We humans have steadily eroded the carrying capacity by taking plants away. So what we have to do is put them back. Where are we going to do that? We have to do it as many places as we can, but we can't avoid privately owned property. 78% of the entire U.S. is privately owned. 86% east of the Mississippi is privately owned. If we ignored the places where we live and work and play, conservation would not work because it would be confined to, at best 15% of the U.S. And again, those sites would be too small and too isolated for it to sustain the species we want it to sustain. So on these private properties, we have to restore nature's relationships. We have to raise the bar about what we've asked our landscapes to do. So in the past, we've asked them to be pretty. That's good. We can keep doing that. But now they also have to support viable food webs. They have to support life. And they're going to do that by putting the right plants back. They have to sequester carbon. Everybody needs to be sequestering carbon now. And it's plants that do that. I had a student a few years ago that said, we need to invent a machine that pulls carbon out of the atmosphere and locks it up and then pumps it into the ground. I said, well, that would be nice, except we already have that machine. It's called a tree. And if we put the trees back, they're pumping carbon, or a lot of our herbaceous plants too, are pumping carbon into the soil as long as they live. We also have to clean and manage our watersheds. Everybody lives in a watershed, everybody. And nobody has the ethical right to destroy that watershed. You manage it by putting the plants back. We have to enrich our soil primarily with carbon, pump that carbon back in, and we've got to support pollinators. Supporting pollinators has been politically correct for a while. And the argument is, well, we have to support them for agriculture. That's not why we have to support pollinators. They say, well, they pollinate a third of our crops. They pollinate 80% of all plants and 90% of all flowering plants. If we were to lose our pollinators, we'd lose 80 to 90% of the plants on the planet. That is not an option. It is simply not an option. Far more important than a few of our fruit trees. So we're not talking about good land stewardship here. We're talking about essential land stewardship. Roy Dennis is a land manager in England who recently said that land ownership is more than a privilege, it's a responsibility. And I couldn't agree with that more. What he's talking about here is the biosphere of the planet, that very thin film of life on the surface of the planet. If the planet was an egg, the biosphere would be thinner than the eggshell. Yet that is where all the life that we know about exists. And who knows, maybe it's all the life in the universe, and it's certainly all the life that we're ever going to interact with in the universe, right there on the biosphere. But we have chopped up that biosphere into private land ownership. So Tom owns this, Dick owns this, Mary owns this. Harry, don't forget Harry, he owns something too. Okay, but along with that private land ownership comes the responsibility of stewarding all the life in the universe. I can't think of a more awesome responsibility than that. This is a church I drove by in Mississippi not long ago, and everybody's inside worshiping God's creations, and on the outside, they're killing them all with this giant dead lawn. We're not thinking. We're just not thinking. So in the past, we've gone to the nursery and we look for plants simply for aesthetical reasons. We thought plants were just decorations. So we buy something that's pretty and then we're happy. But when we landscape with plants just as decorations, it ends up being pretty. It is. But then landscaping equals ecological destruction. We could pick pretty plants that produce ecosystem services, that support our food webs, protect our watershed, that create pollinator habits, support natural enemies. And if we make function one of the criteria that we use when we choose landscape plants, then landscaping equals ecological restoration. And I'm going to call this 21st century landscaping. We've done 20th century landscaping and we're now in the 6th grade extinction. So I'm not impressed with it. Let's give this a try. All right, here are 9 things that you can do to restore the insect populations and thus the ecosystems in your yard. Let's start with the first one. Cut your lawn in half. Now, I know a lot of people in California don't have giant lawns, but it's something to think about anyway, because we got a lot of lawn. Got a lot of lawn in North America. We have an area the size of New England that is in lawn. It's over 40 million acres, and it is a dead zone. And the stuff we put on our lawn and all the mowers that we cut them with are poisoning our environments and our watershed. So let's think about cutting that area in half and putting those keystone plants in the area we take out of lawn. We also want to think about planting for specialist bees. Now, I didn't get a chance to talk about bees in this talk. It's just too long. But bees, of course, critical. We need them to pollinate plants everywhere. And there are a lot of bees that are specialists, meaning they will only reproduce on the pollen of particular plant genera. So in a lot of areas of the country, there are about 13 species of bees that only use sunflower pollen, 12 species that only use aster pollen, 11 species that only use goldenrods, and so on. So if you have sunflowers, asters, goldenrod, evening primrose, willows in your yard, you're supporting more than 50 species of bees. If you don't have those, you've just lost 50 species of bees. The generalist bees will follow these plants. They can use these plants as well, but you lose the specialists when you don't pay attention to these relationships. Remove invasive species from your property. This is a no-brainer. And don't go to the nursery and buy new invasive species. By the way, let's be clear about what an invasive species is. I hear a lot of people talking about native plants being invasive. The definition of an invasive plant is a non-native that's displacing native plant communities. There are natives that can be aggressive, but that's not what invasive means. So if you have a non-native that can easily escape your yard and penetrate your natural areas, remove it and put in one that is not invasive. Okay, use those keystone plants. We talked about that. We want to use those top performing plants. They don't have to be the only plants we use. But if we don't use them, it's like building your house without the 2x4s. Those are the plants that are holding up the relationships in your landscape. You can then decorate around, but we don't build our houses out of wallpaper, and we can't build landscapes without keystone plants. Preserve your leaf litter. What am I talking about? And your ground covers. Again, where I live, Pennsylvania, there are 511 species of caterpillars that develop on oaks in Pennsylvania. A few of them complete their development on the oak tree. This is the polyphemus moth that spins. The caterpillar eats the leaves, and then it spins its cocoon. And then it emerges as an adult and does everything on the tree. And I wish all of the oak beaters did that, but they don't. 94% of them, 480 species, drop from the tree and pupate in the soil. They tunnel it underneath the soil and form their pupa, or they spin a cocoon in the leaf litter under the tree. And that's where the problem comes in, because we don't leave leaf litter under our tree, and we compact our, come back here, we compact our soil and mow it. So this becomes a no man's land for any caterpillar that's trying to complete its development. So these might all be oaks or really high producing trees, but it becomes an ecological trap. You're calling in the moths to lay their eggs, the caterpillars develop, and then they die. And of course, the cement landscape is an even worse alternative. I'm not trying to discourage trees in trees, but I would like to see less cement. This is just laziness in terms of landscaping, and it destroys our watersheds. This is the typical scenario. We have trees growing in the middle of a lawn, and I would like to measure, nobody's measured caterpillar survivorship when they drop out of the trees in a situation like that. I'd like to try to do that this summer if we can, but I can guarantee, and this of course, is that compact soil and no plants here at all. Very tough on a caterpillar. This is what we're going for. We want the tree, but then we want a layered landscape underneath it. We want our native, this is a native azalea here, and our ferns, and, you know, biome specific, but you want plants under those trees that are going to be over ground that is undisturbed. You're not going to go walking through this spring ephemeral garden. You're not going to trample it. You're not going to mow it. And the caterpillars that fall down in here will be able to complete their development without any problem. It's a great place for ground covers, like your yerba buena, good ground cover in California. Caterpillars drop into here, and it's a safe zone. Okay, night lights are killing our insects by the billions. So we need to address this. And this is probably the easiest thing to address. We light up the skies at night. And the excuse is always for security. I think it's just a habit. If you're really worried about security, put a motion sensor on your security light so that it only turns on when the bad man comes. And you would be surprised how often the bad man does not come. Even better, put a yellow light bulb in your security light, or a yellow LED bulb is the best. It's the least attractive to insects. So overnight, if we replaced all of our night lights with yellow LED bulbs, we could save billions of insects almost instantly. Oppose mosquito spraying. You know, we're fogging for mosquitoes all over the country, and we're doing it really for no good reason. Mosquitoes do transmit diseases, but we don't have most of those in this country. We don't have any Zika virus now. This is Mosquito Joe, and he will tell you where these fogs are only killing mosquitoes. Not so. This is pyrethroids. It's killing all the insects it attracts. So, you know, we're trying to build insects in our landscape, and Mosquito Joe comes and kills them all. And it doesn't just stay where he's spraying. It floats over to the neighbors and kills them as well. And he says, well, it's organic. It's totally safe. Organic meaning it comes from a plant, and it does. But cyanide comes from a plant too. That does not make it safe. If you really have a mosquito problem, and I don't know how big your mosquito problems are in California, but this is how you can control them. Get a bucket, fill it full of water, put in some straw or hay, and let it ferment for a day or so, and it becomes irresistible to ovipositing mosquitoes. They lay their eggs in there. When the larvae hatch, you put in a mosquito dunk that you get at the drugstore, hardware store. Put it in, the mosquito larvae eat it. This has got Bacillus thuringiensis in it. It's a mosquito-specific bacterium that kills mosquitoes, only mosquitoes. So you're not hitting any non-targets. It's very effective. It's not very expensive. And if everybody had mosquito dunk traps out there, we'd have far fewer mosquitoes. Minimize insecticide use overall. You realize homeowners use more insecticide per acre than agriculture. And most of it is absolutely unnecessary. It's, you know, we've got this thing, we've got to kill all insects, but we're not actually sure why. We don't. Then finally, there are a lot of rules out there from your homeowners association or your township saying, well, you have to have dead landscapes because we say so. Join your HOA, change from within, you know, penetrate them, infiltrate them. These rules were made by people who didn't understand the ecological relationships around them. We can change those rules. There's nothing sacred about them. So I'm going to end this part of the talk by talking about a book that E.O. Wilson wrote in 2016 called Half Earth. I don't know if any of you read it, but he's making the argument that if we're going to save life on Earth anywhere, we have to save it on half. We have to have ecosystem function on half of planet Earth. And he spends most of the book talking about the science that supports that statement, and then he ends the book. Well, this is a wonderful thing. I'd love to see it happen, but we're scratching our heads saying, well, how can this be possible? Remember, agriculture is already in half of terrestrial planet Earth, and we're stuck in the other half. All 8 billion of us with all of our infrastructure and our airports and our roads and everything else. How can we have functioning ecosystems where we have all of those humans? Well, I actually think we can do it. We can do it by enacting the things I just talked about. We can realize EO's dream, but we need a new approach to conservation. We've had this idea that humans and nature cannot coexist. That's nonsense. Of course we can coexist. As a matter of fact, I think coexisting is now our only option. this is what we have to do. We have to have functioning natural relationships where humans abound. The UN designates biosphere reserves as places of ecological significance, as if not all places have ecological significance. Another crazy thing, every square inch of the planet has ecological significance, including your yard. We can't leave conservation to the conservationists anymore. There's way too much conservation that has to be done and not nearly enough conservationists. So we all have to participate. It doesn't mean you have to save biodiversity for a living, but you really can save it where you live, or if you're ambitious, you can save it where you work as well. I like this approach because it empowers each one of us. And this is a time in our human existence where we want to be empowered. There are a lot of giant environmental problems out there, and most of us feel helpless. But this is one where you can plant that oak, you can plant that native plant and watch the life come to it, make a difference, either on property you own or volunteer in a nearby park or preserve. It also shrinks the problem to something that's manageable for each one of us. Don't worry about the Earth's giant problems. Just worry about your own property, your own little park. Do something, get rid of those invasives, cut that lawn in half, put in those keystone plants, and we'll be happy. So as property owners, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. None of us are going to be able to fix it alone, but we really can fix it if we work together. Thanks very much. So I'm not going to do questions right now. What I am going to do is return to this graph, the one that Mike made, and we're going to talk about many of these, not all of them, and make some start comparisons. And when I was in San Francisco last year, at some point, and I noticed a lot of sweet gums. That's a plant, of course, from the east. I've got sweet gums right in my yard here. It's not a terribly powerful plant. It supports 37 species in my county, but in your county, in near San Francisco, it supports one introduced species. So you can't call it a native just because it's from North America. It's not from California, not producing a lot of food. So you can use that, or you can use that ginkgo we talked about several times and make no caterpillars at all. Or you can put in one of your 39 species of oaks. I think California has more species of oaks than any other state. And of course, then you have the option of making 270 species of caterpillars. That's the pinnacle of our keystone species. You can put your eucalyptus in, or get on one of the committees to save the eucalyptus. They're making 5 caterpillars. I'd love to find one of those because they're sure not very common. Or crepe myrtles, beautiful, but make no caterpillars, just a decoration. Or you could put in one of your 15 species of native prunus, the native cherries, 246 species of caterpillars, just things like your holly leaf cherry, very powerful plants. Tree of Heaven, highly invasive in the east here. That's Ailanthus, supports 2 species of caterpillars. Could be one of your 8 species of native maples, Acer, support 85 species. You see the differences here, stark contrast between the natives and the non-natives. You have 8, or I don't know how many species of acacia. You've got a lot of species of acacia. None of them are native to California. It's a legume. Legumes do make a lot of nitrogen. So you've got 8 species of caterpillars eating them, but it could be a manzanita. You've got 103 species of types of manzanita, support 41 species. There's always a better alternative than a native. Your English ivy, again, highly invasive, supports 6 species. I've never found anything on an English ivy. But you've got 69 species of ribes that together support 83 species of caterpillars, just in California. Those are the currents. And of course, they're very beautiful. That's a good bonus. Cotoneaster, another common non-native a lot of people use, supports 7 species, but it could be a California lilac, one of 100 species of California ceanothus that supports 79 species of caterpillars. Much better alternative. Ocean spray, Holodiscus discolor, is a pretty, and there's only 1 species, but it supports 24 species of caterpillars. It's a good native. Forget-me-nots, very popular, I guess, support 3 species. But it could be a lupine. You got 100 species of lupines in California that support 49 species of caterpillars. Fennel. Now, pollinators, look at these, all honeybees, by the way. That's an introduced native generalist bee. They support 4 species of caterpillars, but the native asters. Now, the asters are broken up into several genera. There's 95 species in California of aster-like plants that look like this. Nobody's measured the number of caterpillars since they broke up the genera, but it is many. It's a top producer back here in the East, and I'm sure it is in California as well. Another non-native, lily of the Nile. Now you see why we're using them. They're pretty. I agree, they're pretty, but no caterpillars. No caterpillars. It's just a decoration. Could be a native goldenrod. You've got 11 species of goldenrods that support 27 species of caterpillars. And boy, that seems low to me. In my yard, it's 110 species. I bet there's more out there in California if we look for them. Periwinkle vinca, another non-native, supports 2 species. Could be a California rose. And you plant them densely enough, you can get a nice ground cover. You've got 21 species of roses, native roses in California, and they support 70 species of caterpillars. Ice plant, another non-native, 0 species of caterpillars. Could be one of your sages, your artemisia, support 21 species. Point is, with natives, we can create landscapes that are both beautiful and functional. Thanks for listening.
So Doug was not able to stay with us today to answer questions. I'm going to answer some of the questions that I saw on the chat for the next few minutes as I talk. This is Kathy Kramer. I'm the garden tour coordinator. So my husband Mike and I made this chart, and Doug went over it, which I was glad to see. But I just want to point out on the right, the species that he talked about that have 0 ecological value. If you have any of these in your own garden, grass, for example, ginkgo, crepe myrtles, tea trees, red hot pokers, periwinkles, ice plant, agapanthus, ivy. These are support like 6 or 8 species of caterpillar, tree of heaven, impatiens, fennel, forget-me-not, eucalyptus, cotoneaster, acacia. So there they are, the unproductive plants that are so often in people's gardens. People asked if this talk will be recorded and put up on the YouTube page, and yes, it will. And you can subscribe to the YouTube channel to be notified when videos are put up. So here are photos of non-native ornamentals: cosmos, hot lip sage, pride of Madeira, lavender. You might have some of these in your own garden, and you might be thinking to yourself, well, I have a lot of non-native ornamentals in my garden, and the butterflies and bees love them. But as Doug said, butterflies are generalists when it comes to finding nectar, but as you just heard, they require specific native plants in order to lay their eggs. And the analogy that comes to my mind is, what if you and I could have all the free coffee at Starbucks that we wanted, but we couldn't reproduce? So we would soon have a population crash also. So I hope that after this morning's talk and through the presentations this weekend, you'll take a Marie Kondo, look at your own garden and ask yourself, does this non-native ornamental spark joy? And if it does, then keep it. If it's a plant that your mother gave you, or you just love it because it's beautiful and you feel you need it in your yard, then you should have that in your yard. But if it doesn't, then consider replacing it with a California native plant that will provide food, shelter, and nesting areas for wildlife. So just to go over some of the things that Doug talked about, I have my 3 things you can do in your garden. Shoot for 50 to 70% native plants in your garden. That still gives you, 30 to 50% of your garden to have other plants that you like. Use Keystone plants, and you can find the Keystone plants on the Garden Tours website, and stop using pesticide. None of the gardens on the Garden Tour, whether you see them this weekend or in person in early May, use any pesticides in their garden. So whether you start small by just changing out a few plants, or whether you go whole hog, then you might want to really work toward having at least 50% natives in your garden. So I'll spend a little bit of time here talking about the garden study that was done by the city of Santa Monica, in case you're not yet convinced to include natives in your garden. This was a 9-year-long study where the city of Santa Monica compared water use, green waste generation, and the number of maintenance hours between a traditional garden, which had a lawn and Mediterranean climate plants, and a native plant garden. Here you can see the 2 gardens, which were side by side in downtown Santa Monica on Pearl Street. And here are the results of the study. On the left in blue, is the amount of water used by the traditional garden. On the right in blue is the amount of water used by the native plant garden in the same time period. The native plant garden used about 80% less water than the traditional garden did. The middle garden in green, the middle column, is the amount of green waste that each garden generated. And what this translates into is either you mowing every week and pruning, or you're paying someone else to do that. And the right side in green shows how much less green waste is generated in a native plant garden. And you can see that the traditional garden generated twice as much green waste as the native plant garden did. Finally, the purple shows the number of maintenance hours required to maintain each garden. So when the people in the traditional garden are spending 80 hours working in their yards, the people with the native plant garden on the right are spending just 15 hours to maintain theirs. Orinda Books has again made the tour a great offer. You can purchase any of the following books from Orinda Books, and a portion of the proceeds will be donated to the tour. You'll also be supporting Orinda Books, a local small business. In this case, the small business is owned by longtime garden tour host Pat Rudebush, whose lovely native plant garden in Orinda you may have visited in the past. You can call Orinda Books at 925-254-7606, or you can order online at orindabooks.com. So Doug Tallamy has a new book out now. It's Nature's Best Hope for middle school students. How you can save the world in your own yard. Purchase this book and help the children in your life take positive action to help wildlife in their gardens. These other books are also on the benefit list. They are California-specific native plant gardening books. Designing California Native Plant Gardens, Plant Community Approach by Allery Middlebrook and Glenn Keeter. Frederic Levapoyer's Garden Allies, which is a really interesting book about the wild, the small things in your garden. Native Plant Gardening for Birds, Bees, and Butterflies in Northern California by George Oxford Miller, or California Native Gardening, a month-by-month guide by Helen Popper. If you are watching today and haven't had a chance yet to make a donation, if you'll please support the tour. You can do it on the tour's website under Please Donate. You can Venmo a contribution to @Bringing Back the Natives. We depend upon donations to keep going, and we hope that if you've enjoyed our presentation, that you will help us to keep this event going.